My name is Nzube Egboluche. I'm a PhD candidate in Bioenvironmental Science program, Morgan State University. My research title, Physiological Impact of Iron Oxide and Copper Oxide Nanoparticles on Seedling Growth of Kidney Bean Plants. Nanoparticles are materials with dimensions between 1 to 100 nanometers, and some of the physical and chemical properties include the optical, mechanical, magnetic, and electrical properties. They are also characterized based on their sizes, surface area, shape, and morphology. These unique properties of nanoparticles make them different and unique from their bulk materials. Due to their unique characteristics, they are used in various applications in industries such as medicine, pharmaceuticals, cosmetics, and even in agricultural industry. In agricultural industry, the application of nanomaterials have the potential to improve agricultural and food products, and also with prospects of addressing global food demand by increasing food crop yield, minimizing loss of nutrient through fertilization, improving plant pests and disease control, and also can be used as an alternative source of nutrients and overall promotion of sustainable agriculture. Nanoparticles have been applied in different agricultural products such as supplement, pesticide, biocide, food additive, food ingredients. This color code shows different kinds of nanoparticle that has been used and applied in these products. However, studies have shown different responses on the effect of nanoparticle on food crops, and this variation in responses could be due to the type of nanoparticles, the plant species, the growth media, and the nanoparticle concentration. The accumulation of nanoparticle in the plant could alter the physiological processes, and there are two major pathways through which nanoparticle can be absorbed and transported through in the plant parts. One is from the root to the leaf through the apoplastic pathway, and second is from the leaf to the root through the stomata. Therefore, it is important that every economic and high consumable food crops should be investigated with different kinds of nanoparticles to ensure high food quality and safety. The objective of my study is to investigate the effect of copper oxide and iron 3 oxide nanoparticle on the seedling growth of kidney bean, and also to determine the bioaccumulation of nanoparticle in plant soil system. Why copper oxide and iron 3 oxide nanoparticle? Copper is a very essential element for plant growth, and copper oxide nanoparticles are known for their antimicrobial properties, therefore have a potential for plant disease management. Iron also plays a major role in plant physiological processes such as photosynthetic activities and legume rhizobium symbiosis. However, they are fixed to soil particles, therefore they are not available for plant use. Given the importance of these elements to plant growth and the low availability of iron to plants, new direction of supplying copper and iron nutrient is highly required. Copper oxide and iron 3 oxide nanoparticle concentration we use ranged from 20 to 500 milligram per kilogram of soil. Control treatments include water, iron 3 oxide, iron 3 chloride, copper oxide, and copper 2 chloride at 500 milligram per kilogram of soil. Garden soils were measured in a pot, and copper oxide or iron 3 oxide nanoparticle at different concentrations were mixed in the soil and homogenized using kitchen blender. This was allowed to incubate for 24 hours before the seeding of kidney bean seeds. Growth condition was maintained in the greenhouse for 30 days under 70 to 80 degrees Fahrenheit. After the addition of treatment, soil pH was measured, and we see from this table that the soluble metal treatment significantly reduced the soil pH compared to the nanoparticle treatments and also water control. Here is the effect of nanoparticle on plant growth, and the first graph shows us the effect of iron 3 oxide nanoparticle on the shoot and the root length of kidney bean, while the second graph shows the effect of copper oxide nanoparticle on the shoot length and the root length of kidney bean. And from this graph, we see that the soluble metal of copper oxide, of iron 3 oxide and iron 3 chloride, and also copper oxide and copper 2 chloride significantly reduced the shoot length and root length of kidney bean compared to the nanoparticle treatments, and also the control. This graph shows the effect of nanoparticle on plant biomass. The first graph, we are looking at the effect of iron 3 oxide nanoparticle on the root fresh and dry way. And we see that the soluble metal of iron 3 oxide and iron 3 chloride reduce the fresh weight of the plant roots, while the root's fresh weight increased as the concentration of iron 3 oxide nanoparticle increased. The second graph shows the effect of copper oxide nanoparticle on the root fresh weight and dry weight of kidney bean. And we also see that the soluble metal of copper oxide and copper 2 chloride significantly reduce the root fresh weight. And as the concentration of copper oxide nanoparticle increased, the root fresh weight also decreased. This graph shows us the uptake of copper metal in the plant root and stem. We see from this graph, we found that there is higher concentration of copper metal in the plant root compared to the stem. And also a significant amount, and also we saw a lower amount of copper metal in the plant with control treatment compared to other treatments. Main findings from this research: one, that the copper oxide and iron 3 oxide nanoparticle increased the shoot growth of kidney bean seedling, while the root growth significantly increased with iron 3 oxide nanoparticle and decreased with copper oxide nanoparticle at 100 and 500 milligrams per kilogram of soil. The soluble metal salt inhibited the shoot and the root growth of kidney bean plant. And also we found a higher concentration of copper metal in the root system than in the stem. The absorbed copper metal was highly localized in the root system and transported from the root to the plant parts through the apoplastic pathway. And this high presence of copper in the plant system could have altered the physiological processes of the plant, such as the root growth. And the plant reduction by the soluble metal treatment is due to the high accumulation of copper metal in the roots, in the plant roots, since the plant roots is in direct contact with the soil medium. With the absorption and transportation of metal elements from the copper and iron 3 oxide nanoparticle treatments, the incorporation of nanoparticle in agrochemicals could be an alternative means of nutrient delivery to plants. Therefore, there is potential benefit of copper oxide and iron 3 oxide nanoparticle to crop growth improvement compared to the soluble metal. Future research: we are currently investigating the environmental impact of nanoparticle on soil microbial communities, and more research is required on the mechanism of action of nanoparticle in the plant system, and also to determine the impact of copper and iron 3 oxide nanoparticle on nutrient use efficiency. I acknowledge the School of Computer, Mathematical and Natural Sciences, Morgan State University, the National Institute of Minority Health and Health Disparity for their financial support for this research, and to my supervisor, Dr. Hantao Yu, Dr. Hua Deng, for their support and guidance through this research. Thank you for your attention.